Okay, it's an even function. So sine function is odd function. That is why a function that is even won't have any constant. So, but we have some argument here. Cosine function, constant function are even function. So it is reasonable to assume that any even function, when written as a Fourier series, would not have any sine function. Why? Because the Bn, when you calculate the Bn for the even function, you will calculate the value will be equals to 0. Okay, so it'll only be a linear sum of the constant function. The, so you got the a naught over 2 and the a n cos n x. Okay, and the cosine functions. Thus, so the Fourier series for the even function would be called a Fourier cosine series. Why? Because there's no sign inside it. Okay, but odd functions will be the opposite. Odd function, because sine is an odd function, but cosine is an even function. Odd functions will only be the linear sum of the sine functions. There won't be any cos terms because all the an will be 0, a naught also 0. So it'll be only bn values you'll find. So you'll call it the Fourier sine series. Okay. So here is the proof lah. If f is an even function, then for every x, f negative x equals to fx. Okay, it's like the cos function lah. Integration from negative to p for fx dx is 2 times integration from 0 to p of fx dx. This you saw in the example 3.1. Okay, how you prove it? Prove it like this lah. How you did example 3.1? Or you can use also the area under the graph. How you use area under the graph? Okay, even function, x axis, y axis. Even function, whatever the shape of the graph here, will be mirrored here. Okay, there will be a mirror here. Okay, is this because the whatever you call it lah, r. Okay, y equals to fx. So this value will be f r. Then f of negative r also equals to fr. Even function, even function fx. So f of negative r is also equals to fr. So the shape on the right will be exactly the shape on the left. Okay, but mirror lah, the y will be the mirror. Y axis will be the mirror. Can you see or not?
Yes, better.
Yeah, so whatever value you take will be here. Another value you take will be here. F of s and f negative s will be the same values. Take any values. Okay. So there's a mirror. Okay. So if you want to take the area from negative r to r, you will integrate f r dr, sorry, fx dx from negative R to R, correct?
Yes, doctor.
Yeah, but because the shape of the graph is same, my graph a bit outline, same both left and right, this area will be the same as this area. Okay, this area A will be same as this area A. So instead of integrating from negative R to R, you just have to integrate from 0 to R fx dx and
Times.
then times 2. Okay, that's the graphical representation proof by using the graph lah, area. So area under the graph or by substitution of the dummy variable z equals to negative x is integration and integrating z is x again. This integration 0 to negative p fx dx is equal to integration from 0 to p fx dx. Okay. How to get prove this? You put the z equals to negative x, then f of negative z will be equal to fz. F of negative z will be equals to fz. This one become p. This one will be 0. The dx will be negative dz. Then you get the negative p to 0, negative fz dz. Then you invert the bounds, and then by using the negative, then change the z vector. Okay, but for odd functions, this will be integration from negative p to p for fx dx will be 0. Okay,
Okay, doctor.
okay. So if f is a function with the period 2 pi, if it's an even function with the period 2 pi, then fx cos nx is still a even function because even function times even function is an even function. Because you put your negative x here, put negative x here, you get back fx, you get back cos nx. Okay, so you get the even function. But you put negative x here for f is an even function. Negative x here, negative x here, you get negative of fx sine nx because sine of negative nx will be negative sine nx, but f negative x will so there's a negative introduced. So f of for f is an even function, fx times sine nx will be an odd function. So if you use this, is this the value is 0. Integration fx sine nx will be 0. So by integration of negative pi to pi fx cos nx will be 2 times from 0 to pi fx cos nx dx. Okay, this one will be 0. So you got simplified the formula from 3.2 and 3.3. You simplify. Okay, you get the Fourier cosine series for even function Don't use it for any function. It's only for
Mhm.
given function. So if you know it's an even function, use this formula. If they ask you to give you the function and ask you to find Fourier cosine series, the question is already assuming the function is an even function and asking you to find the Fourier series. Okay.
Okay, doctor.
Huh?
Okay, doctor.
So you got this so you got this formula, new formula. So instead of 1 over pi, integration so 1 over pi from 0 to pi,
Mm-hmm.
negative pi to pi, you get 2 over pi integration 0 to pi. It's easier to substitute 0 than to substitute negative pi.
Mm-hmm.
But if f is an odd function, so fx cos nx is odd function. So integration negative pi to pi fx cos nx is 0. But integration of this x odd function becomes product is even function. So 2 times integration from 0 to pi. Okay, this is even function. Can or not?
Yes, doctor.
You don't sound very confusing. You don't sound very convincing.
Still nak to digest first.
Okay, so you get the Fourier sine series. This is Fourier sine series, lah.
Mm-hmm.
Okay. Only need to calculate the Bn. Okay. Okay, the question can come in many forms. Question can ask you to find a Fourier sine series or Fourier cosine series. Okay. The question sometimes the Fourier question can be like this lah. They say find the Fourier cosine series for this. Okay, question is okay. If the question say find the Fourier sine series for this. Okay, question is wrong already.
Mm.
Okay, but if it says Fourier sine series for this from 0 to pi, the x is only 0 to pi, then you are free to define from negative pi to 0 and force the function to be a odd function. If the question is Fourier sine series, then it define from 0 to pi.
Mm-hmm.
Okay,
Okay,
okay or not?
doctor. Okay,
Okay,
doctor.
okay so this is a even function. So the Fourier series, instead of finding Fourier series, you just find a Fourier cosine series. And to find the a naught, you just use 2 over pi, integration from 0 to pi. Then for n positive integer, okay, again, 2 over pi, integration 0 to pi, x squared cos nx. You know how to integrate this?
Yes.
You know how to integrate this?
Mm.
Okay, x squared over n first positive, positive, negative, negative, because this is cos. Okay,
Okay, doctor.
so x squared cos nx integrate x squared sin nx over n plus differentiate x squared is 2x over n squared cos nx. Then is minus differentiate 2x uh, get 2, then cos change to sin divided by n squared, now divided by n cube.
Mm.
Once you get constant, you stop lah. If you got square means you have 3 terms. Power of 4 means you get 5 terms. Okay, 1 term more. Okay, then you substitute 0 to pi. Okay, anything with the sine n pi, sine 0 all becomes 0. So you can
Mm-hmm.
actually cancel. Can or not?
What, doctor?
Can or not? You know this is can cancel because sine pi is 0. So this one can cancel.
Okay, constant. Huh.
Okay, and then you put the zero, so sin n pi is 0, sin 0 is 0. So these two parts cancel, you only have this. Even for this, when you put the 0 in, it cancels off. 2 times 0 is 0 lah, so whatever you times here is 0. So for the only non-zero term by using this substitution, uh, 0 is the uh, pi and 0 is pi only lah, when only when you substitute with pi. 2 times 0, 0 so, so you put the pi 2 pi over n squared cos n pi. What is cos n pi?
Cos n pi.
Hmm. What
Negative
is
1.
cos n pi? What is
Negative
cos pi?
1.
No. What is cos pi?
Cos pi.
Hmm.
Negative 1. Cos
But,
pi 1.
correct.
Negative 1.
What is cos 2 pi?
Cos 2 pi. 1.
Hmm. Cos 3 pi?
Negative 1.
Cos 4 pi?
1.
Yeah. So you can see, when it's a even number, it becomes 1. Okay,
Negative
cos n pi, even number becomes 1. Odd number becomes cos n pi. N is odd number becomes cos n pi becomes
1.
odd number.
Negative
Yeah.
1.
So odd number. N is
Yeah.
odd, cos n pi is negative 1. N is even, cos n pi is positive 1. Okay.
Okay, doctor.
Yeah. That is why cos n pi is negative 1 to the power of n. Okay. This with this. So finally you get your fx.
Doctor, can you move the paper outward? Okay, thank you.
Okay. Fx is a naught over 2 plus summation an cos nx. Okay, don't forget a naught over 2.
Okay.
Hmm. So actually it's a nice function. You'll see something like this in your tutorial 5 question 5, I think the last question. Hmm. Okay.
Okay.
Okay, this is a different type, a bit different lah. It's
Mm.
defined not from negative pi to pi, but it still asks you to find Fourier sine series, and then given you period is 2 pi. That means you are forced to have a uh, certain understanding lah, so that of the how the shape of the function when x is negative pi to 0. It's not anything. Okay, from negative pi to 0, you cannot put anything. Fx equals to whatever you like. Huh? It's a certain shape lah, because it's a odd function. Okay, so you see the discussion below, example 3.4. Though the values are fx for negative pi to 0, and x is 0, negative pi to 0 is not given. We must assume that f is an odd function. That is why I asked to find a Fourier sine series. So you put f negative x equals to negative fx. Um, then you work out what is f of x for negative pi to 0. Okay, see, funny, x plus 2
Mm.
and x is equals to x minus 2 when x is between 0 and pi.
Mm.
Okay, so you see, you can fix back at 0, lah, same. Actually, going back to the same thing. F of 0, uh, wait, 10 point. Oh, yeah, it's not given from equals to 0. This is a Gibbs phenomena. Okay, Gibbs phenomena you learn in chapter 4.
Okay, doctor.
Okay, but all the above discussion is not needed to solve this problem. You just need to use Fourier sine series formula. Okay, because period is 2 pi, you just write like that. And in Bn, you just calculate from integration from 0 to pi.
Mm.
Okay, not negative pi to pi, and then negative bx, uh, uh, negative pi to pi, then put x plus 2 times sine nx from negative pi to 0. Okay, no need to put lah. No need to put everything. So
Mhm.
just put uh, 2 over pi, 0 to pi. Okay, so this part no need to do. I'm just showing lah. If you want to, you're interested in seeing this version. Okay, you can even sketch the graph and see why is it an odd function. Okay, then so how sine nx, polynomial times sine nx.
Doctor, can you move up the paper? Okay.
Okay, polynomial times sine nx. You say negative the same polynomial cos nx divided by n
X. Mhm.
negative positive. Next one,
Mm.
differentiate this, you get what? Negative
Mm.
1.
Mm.
Wait, sorry, you don't differentiate this. You get differentiate x minus 2 lah.
Mhm.
The negative sign is left already. So you differentiate x minus 2 is 1.
Yes.
So 1 over n squared sine nx. Okay, and then when you substitute pi and 0, this part you get 0. So you only
No.
substitute, uh,
Mm.
you substitute only pi and substitute only 0. You minus the. But it's cos n pi.
0
Cos n pi.
plus n pi
Hmm,
equal to 0. Right, doctor?
wrong.
Cos. Oh, sorry. Cos n pi equal to negative 1 power of n.
Correct.
Sorry, doctor.
Okay. Cos n pi is negative 1 to power of n.
Yeah.
Okay, this one is 0 already. Then we substitute 0. This is negative 2 is positive 2. But then it's minus. So minus because the lower bound minus. So we 2 n cos 0 is 1. So then Bn, and you got Break it up lah. Is it necessary to break it up? Not really necessary to break up because it doesn't get go to zero for one value. Okay, if it goes to zero for odd and then even, then it's odd and even lah. But it's not going to zero. When even it comes similar form lah. When it odd, it's this form. Okay, so not necessary to break it up, but I'm showing you lah. If you want to break up, this is what you do. But you see, this is a sine function. This is also
Mhm.
sine function. Both are odd functions. Okay, you cannot get a cosine function there because the function is odd. You can't even have a plus a constant. Okay, plus a non-zero constant because that function will be an even function. Okay, constant is a even function. Okay, okay. Example 3.5. Find the Fourier cosine series. Again, same style as example 3.4 is
Mhm.
defined from 0 to pi.
Okay.
Okay. So what you do is you must assume that is an even function. And then because it's a Fourier cosine series, because even function, the part from negative pi to 0 of the function effect already forced. It somehow is forced. Okay, so uh, give you some method lah. You want to convert from odd to okay. Let's say you have fx equals to a naught.
Doctor, can you move the paper down? Okay, thank you.
Okay. Okay, let's say 0 to pi. F is even function. Okay, implies for when x is between negative pi to 0, fx, okay, even so it still be the same. But this is odd function, so you'll become,
Mhm.
you need to put minus a1 x. Okay, a2 square minus a3 x. So this forces the function to be even function. Okay, but if f is odd function when x is between negative pi and 0 for the same function, f will be all the, sorry, negative a naught. This one will take care of it, minus a2 x squared plus a3 x cubed. You get the idea.
Yes, doctor.
Yeah, so this is a cosine is a even function, so the constant remain, but because negative x is a odd, the x is an odd function, you have to put the, make it positive x here. So to make it, force it to be an even function.
Mhm.
Okay. Even though it is not necessary, yeah, you can check it out by drawing the graph, sketching the graph, and then you know it's a even function. So you find a naught, okay, a naught to a pi 0 to pi dx. No need to do from negative pi to pi. So integrate lah. Integration you should know how to do integrate.
Mhm.
Integration. So substitute 0, you get 0. Okay, so you get pi squared minus pi squared over 2 is pi squared over 2 times 2 over pi is pi. Okay, then for positive integers n, okay, an, okay, so pi minus x cos nx, okay, pi minus x cos nx, okay, pi minus x sin nx over n. You remember,
Mhm.
positive, positive, and then next is cos nx over n squared. What is this? Is differentiation of pi minus x. Differentiation of pi minus x is negative 1. Okay, so we get this now. And substitute pi. Substitute pi. Okay, sin n pi is 0. Sin 0 is 0. So this whole thing gone. What is okay, this negative 1 over n squared taken out.
Mhm.
What is cos n pi?
Negative 1 power of n.
Very good. So minus
Mhm.
cos 0 is. What is cos 0?
Cos 0 is equal to minus.
What is cos 0?
Negative cos 0 equal to 1.
1. Yeah. Lower bound minus 1. Okay. It's a lower bound. So it's
Mhm.
yeah. So this negative sign is already taken out.
Mhm.
So don't get confused. This negative sign is taken out. Okay, so this one you can simplify. This one you must do odd and even because for even it becomes 0. Okay. It's much simplified. Okay, so you have this. Okay.
Okay, doctor.
Okay, so last section is because not all functions have period 2 pi, not all functions defined from negative pi to pi. So you have section 3.4, okay, which you will start tomorrow. I'll teach you tomorrow and next week also.
Okay,
Doctor,
doctor.
Yes,
I see why x from 0 to pi, we consider the period as 2 pi.
okay. Mm, fx is defined from 0 to pi. Okay, let's draw the function. Okay, in order to where's the function? Fx is pi minus x from 0 to pi, correct?
Yes, doctor.
Okay. How is the shape of the graph? It's a negative gradient, okay? When it's the shape of the graph, Okay? Okay or not?
Okay, doctor.
This is the shape of the graph. Okay? Then the period is given as, what is
Zero
the
to
period? Oh, period. What is the period given? Is the period given or not?
no, no.
Not given. Period is not given. Period not given. But you asked to find Fourier.
Cosine series.
You are asked to find Fourier cos series. Okay, Fourier cos series means you are forced to assume that the function is even, because you cannot find Fourier cos series for odd function. Okay, are
Okay,
you
doctor.
following? You are forced to assume the function is even. Otherwise, you cannot find Fourier cos series. You must be an even function. Okay, so even function. Even function means the shape on the right and the left must have some connection.
Yes.
F of negative x equals to fx. Okay, when x and 0, okay, f negative x is more than 0. So f of negative x equals to negative x plus negative, what's the function? No, phi minus negative x equals phi plus x. Okay, we want to find lah, because fx is pi minus x. So f negative x will be pi minus negative x. Why? Because negative x is more than 0. Okay or not?
Okay, doctor. Okay.
Yeah. So it's like this now. That means the shape is like this. Okay? This pi plus x lah.
Yeah.
Now, even though the function originally is only defined from 0 to pi, by asking you to find Fourier cosine series, they are indirectly telling you the shape of the graph from negative pi to 0. You understand that part or not? There's an
Oh,
indirect implication from negative pi to 0.
yeah, doctor. Yeah.
So even though they are giving you only from 0 to pi and then saying ask you to find cos, it's an even function. So indirectly, from negative pi to 0 must be this. So now you know the function defined from negative pi to pi already. This the length of this interval is 2 pi. Correct.
Yes, doctor.
So now you got this length is 2 pi. Interval length is 2 pi. You can set any period that is 2 pi or more. You cannot make less than 2 pi because it's already fixed. Within this interval length of 2 pi is fixed. But you can fix for more than 2 pi or more. You can fix the shape. But easiest is to fix 2 pi lah. That's why we assume fx plus 2 pi equals to Perfect. It's assumption only. You can put anything, x plus anything that is more than 2 pi. But it'll be more work lah. Easiest is to assume it is period is 2 pi. Do you get it?
Yes, right there.
So this is about.
Okay,
Okay, so
Doctor.
whenever possible, you try the period is 2 pi. Okay, if not, okay, the question is different, then you do it differently. Like you'll see some other examples next section. Okay, okay. Okay, so I think that's it for today. Time is 4:58. Okay, see you all tomorrow morning 8 o'clock.
Thank you, Doctor.
Okay.